Okay, so this chapter is simple harmonic motion, which is also called oscillation. Suppose we have this circle. This is the center of the circle, and the horizontal line passing through the center of the circle is considered a reference line. Mean all displacements. Okay, so this horizontal line is called the reference line, and all displacements are measured from this line. Suppose this edge of the circle is marked as a cross. So the displacement of this cross mark from the reference line is 0. Now we rotate the circle either in the clockwise direction or in the anti-clockwise direction. Suppose in this direction. When this cross mark reaches here, then its displacement from the line, reference line is this, and it is not 0, represented by x force. So when this cross reaches here, this is its displacement, and this is the maximum displacement, which is exactly equal to the radius of the circle. On further rotation, when the cross mark reaches here, its displacement from the equilibrium reference line is this, which is not 0, but when it reaches here, its displacement is 0. Look, initially the displacement was 0. It was increasing up to this, and then it starts decreasing, and finally here it becomes 0. Now on the further rotation, when the cross mark reaches here, it is the other side of the reference line, so its displacement from the line will be negative displacement. When the cross mark reaches here, its displacement will be the maximum, but negative, equal to the radius. When it is here, again, it's negative displacement, smaller than the maximum, but more than the 0. So the magnitude of the displacement starts from 0, it increases in the positive direction, it remains in the positive but decreases, it goes to the negative direction, it increases, and then it decreases but remains in the negative direction. So we have to draw the graph of displacement against time. So displacement is dependent and the time is independent. Time at the x-axis, displacement in the meter at the y-axis, this is 0 and this is minus x. So it is initially 0, it increases, maximum then becomes 0, but this is positive side, and then it becomes negative, it increases, then decreases. So this is the graph for the displacement in the circular motion. So this is displacement against time graph for the mark, this cross. Now, this graph is sine graph. The shape of the graph is sine graph. It is sinusoidal graph. So it has some equation. So अब इसकी equation बनानी है. To develop the equation, first draw a line here, then draw a line here. This line is the displacement. This is the angle theta, and this is radius, which is equal to x naught. So in this right angle triangle, this x is opposite to the angle, so it's perpendicular, and this x naught radius is opposite to the 90-degree angle, so it's hypotenuse. So we can write, some people have curly brown hair, so some people have mean sine theta perpendicular over hypotenuse. So sine theta, perpendicular is x and hypotenuse is x naught. So we can write x is equal to x naught sine theta. So probably this is the equation for this graph because we have to find sine equation. We check it. This is the point where the angle swept is 0. So we substitute angle here 0, sine 0, 0. So 0 times x naught, so x 0. Then we reach here at this point top. The angle swept are the 90 degree. Sine 90 is 1. So 1 times x naught is x naught. So definitely at this point, it is x naught. When we are here, angle 180 from the starting position, so sine 180 is 0, so it becomes 0. Then at this point, the angles are 270, sine 270 minus 1, so it becomes minus x naught. So this is maximum, but minus x naught. And then finally, full rotation 360, sine 360 is 0, so x 0, so this is 0. It means 0, 90 degree, 180 degree, 270, and 360. It means this equation is suitable for this rotation, but the graph is between x and t. Yes, there is an x, but there is no t in the equation. So we have to convert this equation into x as well. So x is equal to x naught sine, and theta is the distance. Which distance? The angular distance. So theta can be written as angular speed into time. So now the equation has both displacement and time. So this is the equation for this graph. X is equal to x naught sine omega. This is displacement against time graph. And remember, gradient of displacement time graph is velocity. So when we will draw the graph for gradient of displacement time, suppose x-axis is t, y-axis is acceleration. So here the gradient is positive and maximum. At this turning point, the gradient is 0. And this point, the gradient is maximum but negative. So this is negative maximum. And at this point turning, the gradient is 0. At this point, the gradient maximum and positive. So these are the 5 points. When you will join them, the shape of the graph is this. Sorry, this is not acceleration. This is velocity, because gradient and displacement time graph is velocity. This is velocity time graph. Okay, so look at two graphs. Displacement time graph and its gradient, velocity time graph. When gradient is maximum, velocity maximum, gradient turning point 0, velocity 0, gradient maximum negative, velocity negative, turning point 0, and positive gradient. Now we have to write equation for this. This is not sine graph, this is cos graph. For the sine, we wrote here x is equal to x naught sine theta. So similarly, we can write v is equal to v naught cos theta. X is equal to x naught sine theta, v is equal to v naught cos theta. But we know that v velocity is in circular motion is r omega. When r is here x naught omega, so we can replace v naught with x naught omega. So v is equal to x naught omega or cos theta omega t. So this is the graph for this velocity against time. So the first, x is equal to x naught omega t, and the second, v is equal to v naught cos omega t. So two graphs, one for displacement, other for the velocity. Now, we know that the gradient of velocity against time graph is acceleration. So the next graph is acceleration at the y-axis and the time at the x-axis. Look at the both graphs. So here the gradient is 0, so acceleration is 0. At this point, the gradient is maximum but negative. So here acceleration is maximum but negative. At this point, the gradient is 0, turning point. So acceleration is 0. So at this point, the gradient maximum and positive. So it's maximum positive. And at this point, turning point, the gradient is 0. So 1, 2, 3, 4, 5. So again, this is the graph. This is acceleration against time graph. Now the equation for this. Look, the first graph is the sine graph, this one. And this graph is the reciprocal of this, mean it is the reflection of the first graph. So if this is sine graph, then this will be minus sine graph. So iska ulta hai beta. So it is called the minus sine graph. So we can write again, A is equal to A naught minus sine theta graph. But in circular motion, A is equal to R omega square. Here R is x naught omega square, and this must be A naught. So A naught can be replaced with x naught omega square and minus sine theta omega t. So the finally we have equation A is equal to minus x naught omega square into sine omega t. So 3 graphs and 3 equations. Okay, now look at first and the last graph. When displacement is positive, acceleration 100% negative. When displacement is negative, acceleration 100% positive. So the conclusion is acceleration and displacement are opposite in direction. This is the first result. Number 2, when displacement is 0, acceleration is 0. When displacement is maximum, acceleration also maximum but in the opposite direction. Direction हम पहले discuss कर चुके हैं. When again displacement 0, acceleration 0, displacement maximum, acceleration maximum, displacement 0, acceleration 0. So the number 2, both are directly proportional to each other. Mean A and X are opposite in direction, but they are directly proportional. To each other. These are the 2 conclusions. So we can write a motion in which acceleration is directly proportional to displacement and opposite in direction is called simple harmonic motion. So I repeat, a motion in which acceleration directly proportional to displacement but opposite in direction is called simple harmonic motion. Mean A and X both are directly proportional, but they are opposite in direction. So this is sign for the directly proportional, this is sign for the opposite direction. And sometimes instead of the opposite direction, it is also written as acceleration directed towards mean position. So this and this opposite direction has same meaning. So in definition, we can write opposite in direction or simply acceleration directed towards the mean position, but try to write this one, a motion in which acceleration directly proportional to displacement and opposite in direction, or acceleration directly proportional to displacement and it is directed towards mean position. Okay, now both are directly proportional. So straight line passing through the origin. So this is acceleration, this is displacement, both are vector. So due to direction, positive and negative both sides, this is 0. So straight line passing through the origin. But the problem is, this is negative sign. Negative sign says when displacement is positive, acceleration must be negative. When displacement negative, acceleration must be positive. For this, we have to draw a graph like this. Look, straight line passing through the origin, so directly proportional. When displacement positive, acceleration negative. When displacement negative, acceleration positive. So this is the graph between A and X, directly but opposite in direction. Now, this equation can be written as A is equal to constant times minus X. There must be a constant to make the equation. इस relation की equation बनाना तो constant है. अब हम कहीं से constant निकालते हैं. Look at the final equation जो graph हमने की थी. This is homogeneous equation. This portion has no unit. Then the rest is similar to the last equation. This one, A is equal to minus X naught omega square. Now compare these two equations. A, yes, A is there. Minus, yes, minus there. Displacement, displacement. So what's remaining? Omega. So it means here the omega square is the constant. So we will write here A is equal to minus X omega square. So this is the equation for this graph. This is the fourth graph. A is equal to minus X omega square. Mean whenever we will calculate the gradient of this graph, which is equal to A over X minus, it is omega square. So the gradient of this graph is omega square, and from omega we can calculate frequency. From omega we can calculate time period as well. So this is simple harmonic motion graph with its gradient. This graph and this graph both are compared. Now the comparison between first and the second graph. Look, when displacement is positive, velocity positive as well as negative. When displacement negative, velocity negative as well as positive. It means for the positive displacement, we can't rely on the velocity. It can be positive, it can be negative in both directions. Okay. Look, when displacement is zero, it is maximum. When displacement maximum, it's zero. एक तो बेटा पॉजिटिव नेगेटिव है और दूसरा ऑपोजिट है. So now we have to draw the graph which is between velocity and displacement. This is displacement positive, this is negative displacement, this is the velocity, and this is the negative velocity. This is this. Suppose this is the maximum displacement, this is maximum negative displacement, this is maximum velocity, and this is maximum velocity in the opposite direction. Look, when displacement is zero, sometimes velocity maximum positive, sometimes velocity negative. When displacement is maximum, velocity is zero, so maximum positive, velocity zero, negative maximum, velocity zero. So we have four graphs. So the graph between velocity and displacement is join these 4 points. So this is the velocity against displacement graph. It's an oval shape, not a circle. Now the equation for this, very, very important. First graph. First graph was between displacement and time, and its equation was x is equal to x naught sine theta. And the second graph is between velocity and time, and its equation is v is equal to x naught omega cos theta or cos omega t. Now from the first, we can write sine theta is equal to x over x naught, and the cos theta is equal to v over x naught omega. Okay. Now, according to the maths, sine square theta plus cos square theta is equal to 1. So substitute sine and cos here. So it is x over x naught square. It is v over x naught omega whole square is equal to 1. Now open the square. So x square over x naught square, v square over x naught square omega square is equal to 1. Now multiply both sides by x naught square omega square. So here x naught square omega square, here x naught square omega square, x naught square omega square, or add simply by taking the LCM. It's up to you. So x naught cancelled, this whole cancelled. So here it is x square omega square plus v square x naught square omega square, which can be written as v square x naught square omega square minus x square omega square. Now v square is equal to, what is common here? Omega square bracket x naught square minus x square. Now what is the difference between x naught and x? X is the displacement just, and x naught is the maximum displacement. And the maximum displacement is called amplitude. So we can substitute omega square, this is maximum displacement amplitude, so amplitude square minus displacement square, and finally the equation is v is equal to under root of this, So under root of omega square amplitude square minus x square, or we can write plus minus omega square under root omega and under root of amplitude square minus x square. So this is the velocity against displacement equation for this graph. This is the graph. So this is V is equal to plus minus omega under root amplitude square minus x square. Okay, suppose here displacement is 0. So we substitute this x0. Then under root is cancelled. It becomes V is equal to omega A. So V is equal to omega into AX naught. So this is the maximum velocity. Yes, it's maximum, plus minus. But when this displacement is maximum, we will substitute V is equal to plus minus omega amplitude square minus displacement maximum x naught square. This is also x naught square. So cancelled, 0, velocity 0, look, velocity 0. So it means this equation, which is V is equal to plus minus omega amplitude square minus x square, is the final equation for this graph.